we're going to look at conditional probability, and I will now briefly explain what that means, and then we'll go on to some actual questions. Now, the first thing I want to say is given means if I know. So here's an example. You might be asked this question: find the probability that my dice roll is 2 given it is even. So if we just replace that word given with if I know, here's the sentence. Find the probability that my dice roll is 2 if I know that it is even. So if you know that extra information that it's even, the probability actually changes. So normally the probability that your dice roll is 2 is 1 over 6, because there's 1, 2, and 6 outcomes in total. But as you'll see, the probability changes a little bit, and the result of this word given is that you have to actually make the sample space smaller. So we'll do an example of that. Find the probability that my dice roll is 2. What's the sample space and what's the probability? So let's just write out the sample space. Okay, so that's the sample space. What's the probability? Well, I only have one number in there that's 2, so that's 1 over 6, as we just discussed. Now, find the probability that my dice roll is 2, given that it is even. So now I can make my sample space smaller because I know that it's even. So I know that it can't be 1 or 3 or 5. So that means my sample space is smaller. It can only be 2 or 4 or 6 because you know it can't be the others. So that means my new sample space is 2, 4, and 6. So the probability is 1 divided by 3. Now hopefully that makes sense. By the way, let's say we had 2 events. One of them is my dice roll is 2, and the other one is being even. So let's say this is the event T, and this is the event E. If you are asked this question, the way of writing that in symbols would be the probability of getting T given is a vertical line, given E. So this is the probability of T given E, or the probability that my dice roll is 2 given that it's even. Okay, now sometimes you can use a Venn diagram or a two-way table, and I'll show you how this works. Find the probability the number from 1 to 16 is a multiple of 2, given that it is a multiple of 3. So let's say this is A, event A is a multiple of 3, and event B is a multiple of 2. So let's put all the multiples of 2 in here. Alright, so what we have to do, we've got a big sample space of 16 originally, but we find the probability that a number from 1 to 16 is a multiple of 2, given that it's a multiple of 3. So we actually know that, we already know that it's a multiple of 3. We can replace this with if I know that it's a multiple of 3. So we know it has to be in the blue circle. That means we've only got a sample space of 5 numbers. 3, 6, 9, 12, 15. And we're finding the probability that's a multiple of 2. So we're basically finding the probability of B given A. We know that it's A. And that would be these two over here, 2 divided by 5. Because we've got 5 outcomes in the sample space, really. 5 possible outcomes. And 2 of those are even. Okay. How about this question? A die is rolled 3 times. Find the probability that you get 3 even numbers given the first 2 numbers are even. So, I want to save you some time here. If you have 3 stages with like a dice being rolled 3 times, you might think, okay, from step 2 in the probability steps that we had before, you draw a tree diagram to represent the 3 stages. But I want you to just read this question very carefully and think about if we really have to do this, because this is not really going to be possible to draw in the space that we've got. You know, the normal tree diagram, 1, 2, 3, 4, 5, 6. And then for each of these we draw 6 options. And then for each of these we draw 6 options. That's not going to work. So how do we make this easier? And the way we do that is think about the fact that the first 2 numbers are even. So that means I've got an even number, then an even number, then an even number. There's a couple of things you can do. First of all, you can simplify the tree diagram to be even numbers and odd numbers. And you know that the probability of getting an even number and odd number is half of the numbers are even and half of them are odd. So we can do that again. Even, odd, even, odd. So this is a lot better. And I could keep going with that. Or I could recognize that the first 2 numbers are even, so we know that. That means all we need is for the last number to be even. And really, it doesn't even matter what the first 2 numbers were. We can actually just ignore them because we know that they were even. And so all we need to work out is the last number even? So really all you have to do, you've actually only got a sample space of 6 options. You only have to list the options for the last roll, because we already know what the other 2 rolls were, and we just need to work out what's the chance of this last roll being even. So we've got 3 options out of 6, and the probability is 3 out of 6. So you can see that understanding the problem and what's actually happening here goes a long way to helping you save time and avoid impossible diagrams. Okay, thanks for watching.